Hello everyone. This video is intended to help you with vector addition and subtraction. As someone in class put it, we are basically being told hypotenuses, that's plural for hypotenuse, I guess, and we are adding up all their x components and y components. So that we did this example in class, and I've drawn my vector diagram here on the left, and you can see that I started with A, and then I attached B, and the resultant is always from the beginning to the end. And to help you visualize this, we're basically adding all the horizontal and vertical components of these vectors to find the resultant vector. So I've drawn A over here again, so we could look at it individually. A points 40 degrees south of east and has a length of 1,200 meters. So we can't just add things at random angles. We have to break them into their x and y. And to find the x component of this triangle, we must use cosine. For the y component, or the vertical, we must use sine because it's opposite the angle. I've done the same here with vector b. It's up and to the left at 75 degrees. And to find the horizontal component, it's going to be cosine. The vertical component will be sine. So this is to help you visualize. Like when we do the summation of the vectors in the x, we're adding these two together to get a resultant. That's all we're doing. We're adding the horizontal sides of triangles. When we want to get the resultant in the y, we're adding the 2y component of these vectors to get a resultant in the y. That's all we're doing. We're just splitting these vectors that are at angles into their perpendicular components. If that sounds fancy, you're given a hypotenuse, find the sides of a triangle. It's that simple. That's all we're doing. The math that goes with this is if I want to find the resultant in the x-axis, I would add how much a points in the x and how much y points in the x. Y, I'm good. B points in the x, my fault. Simply doing this, I have 1,200 meters to the right at an angle of 40 degrees. We use cosine. B is to the left, so that's minus 1,500 meters because it's left. Cosine 75. That's it. That's how I've added the x component of A and the x component of B. And I don't know why I wrote y there. This video will not be edited. And we just add them together. I'm doing this in my calculator right now. 1,200 cosine 40 minus 1,500 cosine 75. I get a number. That's it. The sum of these two vectors add up to 531 meters in the x-axis. I will now do the y by adding how much each points in the y. So ry is simply 1,200, but it's down. A is pointing down, so negative 1,200 meters sine of 40 degrees. B points up, so it's positive 1,500 meters, sine 75 degrees. Again, all I'm doing is trying to figure out how much does A point in the y-axis? How much does B point in the y-axis? And then I'm going to add them together to get how much R, our resultant, points in the y-axis. That's all we're doing. So negative 1,200 sine 40 plus 1,500 sine 75 is 678. That's it. Now I know how much our resultant points in the x and the y. Basically, I know that this is 531 meters. That's my rx. My ry is positive 678. And my resultant is there. And I don't know the angle. And by now, you should know this phrase, Pythag, inverse tan. To find r, you're just Pythagging. I mean, it's just r equals the square root of 531 meters squared plus 678 meters squared. That's it. You have two sides of a triangle. Find the hypotenuse. Don't make this complicated. So I'm doing it on my calculator now. Because I didn't do these calculations before the video, apologies for this. Just trying to get some content out there. 861 meters. Yay! I know that's different than the answer that's provided. I must have screwed something up in the past. How do you get that angle? Well, we know the angle and we know the opposite and adjacent sides. So we're going to use the tangent inverse of always the y. Well, not always. Most of the time, y over x. And we get the inverse tan. Should have done these calculations earlier, but again, just trying to pump out some content here. 51.9 degrees, and I would say that this is north of east. That's it. So that is our resultant. 861 meters in a direction of 51.9 degrees north of east. The other one we did in class is known as vector subtraction. It's no different. The first one I just showed you there is vector addition because we were able to add a plus b and get a resultant. This problem here, they give you a, you don't know b, but they tell you where you end up. And again, we did this in class. So we know the resultant is somewhere south of east, 500 meters. Did I write 1500 here? Oh, well, there we go. Now it says 500. So we always add a plus b, and then that's our resultant. Here, we know that we go up and to the left, and we know we have to end up, as our resultant, down and to the right. Well, just attach b, and there you go, b. And it's measured with respect to the horizontal. All angles are measured with respect to the horizontal. That's it. So now I'm going to draw b here. We don't know what it is, but we know that it points to the right. That would be bx, and it points down. That's by at some angle. Again, we know the hypotenuses of, that can't be the right word, whatever the plural of hypotenuse is, we know many of them, for each triangle here, for A and for the resultant, and we need to break that up into its x and add them together, and y components so that we can add them together, and then we can get what b is. Technically, we're going to subtract them. Hence, this is called vector subtraction, but there's really no difference. We're going to write out that the resultant in the x is equal to ax plus bx. Well, resultant in the x, since it points to the right, and we know what it is 500 meters, cosine 15 degrees. Ax is to the left, so it's negative 1200 meters, at an angle of 30 degrees. We don't know what bx is. And this is why they call it vector subtraction, because technically you're going to subtract this over here. I know it's negative, but think of it as subtracting a negative. That's terrible language. But don't let vector subtraction versus vector addition bother you. I still wrote out the same starting expression right here. So what's the difference? Just solve for the unknown. So we have 500 cosine 15 plus 1200 cosine 30. And I get that bx is roughly 1,522 meters. I'm just entertaining myself. I'm sorry. The resultant in the y is the sum of ay and by. Y is pointing down, ry, so I'm going to put negative 500 meters at an angle of 15 degrees. So I'm doing sine 15. Never use negative angles. What are you, crazy? The negative is already taken care of with the in front of the 500. Ay is pointing up, so that's 1,200 meters. Sine 30. And we don't know what by is. Aw. But we can find it because it's the only thing we don't know here. So negative 500 sine 15 minus 1,200 sine 30. And we get negative 729 meters. Now this matches our diagram, by the way, because B, as I've drawn it right here, is down and to the right. So we should have a positive x and a negative y. How do we figure out what B really equals? Well, Pythag inverse tan, people. You have the x and y components of this vector, and we need to put them together to find the resultant vector. And if that language bothers you, tough luck. Seriously, though, you have two sides of a triangle and you're finding a hypotenuse. I know you can do this. Your AP. I got that B is equal to 1688. I know the answer does not match the answer provided in the problem. And we want to get that angle. Here we go. Theta is equal to the tangent inverse. Always the y over the x. I keep saying always, but it's not always, always. So I'm sorry. Most of the time. And this is 1522. And we get inverse tangent of 729 divided by 1522. And we get 25.6 degrees. But which way is it pointing? Going back up, in case you forgot, it is down and to the right, or south of east. And that's it, peoples. I really do hope this video helps, because I know that this can be a little weird at first, but please understand, you're given hypotenuse of triangles, and you're trying to find the sides and combine them together. That's all we're doing, and you're going to see this again in forces. So I hope this video was helpful in some way, shape, or form. I would probably give this video roughly 3 out of 5 stars. I wouldn't change a thing.